A spirometer is used to measure expiratory volumes. These volumes then can be used to determine pulmonary function. The first diagnostic measurement is forced vital capacity, or FVC. Vital capacity is the maximum amount of air that can move in and out of the lungs. It is the sum of tidal volume plus inspiratory reserve volume plus expiratory reserve volume. In forced vital capacity, you are taking in a deep breath and then blowing out the air into the spirometer as hard and as rapid as possible until you can no longer blow out. The definition for FVC is the amount of gas expelled after forced inspiration and then rapid forced expiration. Let's look at this graph. On the x-axis is time in seconds. On the y-axis is volume in liters. This would be 1 liter, 2, 3, and 4. At this point, the patient begins to blow into the spirometer after taking a forced inspiration. So they've taken a breath, a deep breath, and now they're blowing into the spirometer. They continue to blow as rapid and hard as they can until all the air leaves the lungs. We can tell when all the air has left the lungs because the volume no longer continues to climb. Vital capacity on average is about 4.8 liters. This will vary though, depending upon gender, height, and age. The second diagnostic measurement is forced expiratory volume, or FEV. This is the percentage of vital capacity exhaled during specific time intervals. For diagnostic purposes, the time interval is usually the first second. We can designate the first second by putting a subscript 1, FEV1. Using a spirograph, you can determine the FEV1. Recall that the patient begins to blow into the spirometer at this point, continues to blow as rapid and as hard as they possibly can until they can no longer blow any more air out, and at that point, the graph levels off. To determine the FEV1, you'll go to the 1 second on the x-axis, draw a line up to the data graph, the point here, until it intersects. From there, draw another line over to the y-axis to see what the volume is. Let's put this into practice. Pulmonary function can be calculated using this equation, where FEV1 is divided by FVC. The decimal you get from this division is then multiplied times 100 to give you a percentage. Normal pulmonary function will be around 80%. In order to do a calculation and determine pulmonary function, you will first have to determine FVC. What you're going to do is you're going to take your graph and look at the curve and notice where it levels off. When you find where it levels off, you're going to draw a line over to the y-axis, and that will be your FVC. To determine FEV1, you're going to go down to the x-axis, find your 1 second, draw a line up to where it intersects the curve, and then draw another line over to the y-axis, and that will give you the FEV1. Using this graph, I have determined that the FVC is going to be around 4.5 liters. The FEV1 will be around 3.6 liters. When I divide the 3.6 by 4.5, I will get 0.80. I will then multiply that times 100 to convert it into a percentage, and this is normal pulmonary function, which means healthy lungs will expire 80% of the FVC within the first second. There are two types of lung disorders, obstructive and restrictive. An obstructive lung disorder occurs when a patient is unable to exhale the air located within the lungs. COPD is an obstructive lung disorder. The two main types of COPD are emphysema and chronic bronchitis. Think of obstruction. There is something that is slowing down the movement of the air out of the lungs. In obstructive lung disorders, the patient will have a low FEV1 as well as a low FVC. The FVC for a young adult male will be around 4.8 liters, and a normal percentage will be about 80%. In this case, the percentage will be lower than 80%, typically around 40%. Restrictive disorders occur when the lungs cannot expand fully. This may be the result of obesity, neuromuscular disorders, or age-related arthritis. Since the lungs cannot expand completely, the amount of air brought in during inspiration will be decreased. As a result, the FVC will be lower than normal. However, the FEV will fall within the normal range or even be high. Thus, the percentage will be 80% or higher. Time for application. In this barograph, we have 3 readings. On the x-axis, you have time in seconds, and this is the 1 second point. On the y-axis, you're going to have volume in liters. Let's begin with the yellow reading. The FVC is approximately 3.1 liters. The FEV1 is approximately 2.5 liters. Plugging those measurements into the equation, we come up with 81%. 81% is close to that 80% that is normal. However, look at the FVC. On the test, I will be using examples from a young adult male, and the FVC for a young adult male is 4.8 liters. Therefore, this FVC is low. If the FVC is low, but the percentage is within the normal range or higher, you have a restrictive lung disorder. Let's move on to the blue reading. The FVC will be approximately 2.7 liters. The FEV1 will be approximately 1.2 liters. If you plug the measurements into the equation, you will get 44%. This is low. In addition, the FVC is low as well. This individual, therefore, will have an obstructive lung disorder.